Solving equations with rational expressions. First, let's remember the difference between these two things. Both of them have fractions, so both have rational expressions, but to be an equation, you need to have an equal sign. And for an equation, you solve, so you want to know the answer to the x on those. The other one is just an expression, so it is adding fractions. You have to get the common denominator. So a different kind of problem, so watch for your equals. Before we can solve these equations, we have to talk about domain because we have some variables in the denominator. Remember, we are not allowed to have 0 in a denominator. So we have to find out what would make this equation undefined and throw those values out. So we're going to check the denominators, set them equal to 0 and solve. Anything that would make it equal to 0 will have to be thrown out because that would make it undefined. So if I wanted to find the domain for this problem, I'm going to start with all real numbers and state exclusions. So I'm going to find what to throw away. If I look at this denominator, 2x minus 9, I want to know when is that equal to 0 because that is a bad value. I can't have 0 in the denominator. So this is a linear equation. Add your 9 to both sides. So 2x equals 9. And divide by 2, x equals 9 halves. If we plugged in 9 halves here, it would cancel the 2 and give us 9 minus 9 is 0. So we would get a piece that's undefined. So we're going to throw 9 halves away. You have to do this for every piece that has a variable in the denominator. So we set 5x equal to 0. Divide by 5. So x equals 0. So 0 itself is bad. And also for our last term, it will be 0 itself. So when we write our domain, if we do it with set builder notation, I'm going to say the set of all x such that x is an element of the reals and x is not equal to 0 and 9 halves. First, we will practice finding the domain for some functions. So for this one, the only thing we're worried about is that denominator. That denominator cannot equal 0. You might be able to just look at it. Negative 5 is going to be your bad value. If you don't see it, set the denominator equal to 0 and solve. So subtract your 5 from both sides. So x equals negative 5. Remember, that's what you want to throw away. So your note template already has part of this written, and you're just going to say, okay, I'm going to throw away negative 5. For our next problem, to find the domain, we just check out that denominator, see when it's going to be equal to 0. This is one we solved in that original example. So set the 5x equal to 0, divide by 5. So x equals 0 is the bad value. That's what we don't want to get. So the set of all x such that x is a real number and x is not equal to 0. We're still finding the domain before we get ready to solve. This one's going to take a little bit more work because your denominator is a quadratic. So remember, we will have to factor those. So we want to know when this whole thing is equal to 0. So we will factor and then use the zero product law. So if we try to factor there, split our x's, different signs. And how about 6 and 1? And we want the 6 with the minus. So we want to know when that's equal to 0. You break it apart. Either this piece is 0 or the other part is 0. So for this one, subtract your 1. So x equals negative 1 is bad. This one, add your 6. X equals 6 is bad. Domain is x such that x is a real number and x is not equal to negative 1 and 6. For our last problem, we want to still find the domain. We look at the denominator and we want to know, well, when is this denominator going to be 0? This particular denominator is never going to be 0 because there is no variable there. This denominator will always be 36. So there is no exclusion. There's not anything that will make this undefined once you solve it. So our domain would just be x's all real numbers. So now we've done the prep work for solving these equations with rational expressions. So we make sure it has an equal symbol, and we have to worry about domain. We actually will write our exclusions before we solve, and then at the end, if we get one of those exclusions for our answer, we have to throw it away. This will save us from having to check every single one. So it's a good idea. Write your exclusions first. We're going to look at two methods of solving these equations with rational expressions. One is if there is only one fraction on each side of the equal sign, we can solve it as a proportion and do a cross product. The other is just to clear the fractions like we did in a normal equation that contained fractions. I will do one example of each here, and then I'll do a separate video for each type. So for this problem, when we look at it, first thing we want to notice is it is a solved problem. It has the equals. This one is a proportion because it has one fraction on each side. So we will solve it with that technique. The first thing you have to do after you decide it's an equation is check about your domain. So we're going to have to throw away two values here, anything that would make a denominator 0. So for our first one, if we set it equal to 0 and solve, it's going to be a 2. So we're going to throw 2 away. For the other fraction, we're going to throw away -6. -6 plus 6 is 0. You can set those equal to 0 and solve if you don't see it. For a proportion, to solve, you do cross products. So you're going to multiply on the diagonal across the equal sign. Remember, you're going to need parentheses here. So we're going to have 3 times x plus 6 will be equal to the other cross product, which will be 5 times x minus 2. And now we will simplify and solve. So distribute your 3. So we have 3x plus 18. On the other side, distribute your 5. 5x minus 10. It's a linear equation. Get rid of your x on one side. So I'm going to subtract 5x. Will give me -2x plus 18 equals -10. And now you have a standard linear equation. Get rid of your 18, so we're going to subtract it. You have to watch your signs here. So if -2x equals like signs, add, keep the sign. -28. Back on your side with your equals, you're going to divide by -2. So x equals positive, because you have two negatives, 14. Now, before you finish and say that's the solution, you have to make sure that you didn't throw 14 away. You threw away 2 and you threw away -6. So that's okay. 14 is the solution. We'll do one problem here with the other solve method, and then I'll do a separate video of each. Right? So first of all, you want to notice your equals. It is an equation. You do have a fraction there. So it is an equation with a rational expression. You do have to make sure about any exclusions. We only have one denominator, and so the only thing that's bad is going to be 0 itself here. So we're going to throw that away just like we did on the other type with proportions. Throw away 0. For this kind, you have to pick the common denominator of all your fractions. Our common denominator is a. So figure that out. We're going to multiply every term on both sides by a. This is to clear your fractions. You can use parentheses. I like to actually write it beside each piece myself. So it has to be every piece, whether there's a fraction or not. And then you're going to clean up. So this one, there's nothing to cancel. I have a times 1 is a. In my second piece, my a's will cancel to leave me minus 20. And this side will give me 11a. There's nothing to cancel. Now, get your a terms on the same side. So I'm going to subtract an a. So I have negative 20 equals 10a. Work on your side with your variable, so you need to divide by 10. So I have a equals, and 10 will go into negative 20, a negative 2 times. Now, remember you have to look back and make sure you didn't throw this value away. We threw away 0, so negative 2 is fine. That is our solution to the equation. So this is when it is not just one fraction on each side.